So we're looking at here are proportions. We have ratios that are equal to each other. So for the first couple, trying to find x, it's going to be a simple cross multiply and divide. So like for number 1 here, here's our missing number right there. So we look for the two numbers that are diagonal with each other. Those are the ones we're going to multiply. Which two numbers do we multiply here? 7 times 8 makes 56, excuse me. So then what do we do with the 28? We divide by the 28, gives us 2. So x equals 2. Now the long version of that process would have been cross multiplying in both directions. So you cross multiply in this direction, 7 times 8 is 56. That has to equal what we get when we cross multiply the other direction. X times 28 is 28x. And then you solve that equation by dividing by 28. Gives you 2 equals x. The reason I show you that longer process is in some of these we're going to have to do it that way. So number 2 here, we could just cross multiply and divide because we just have an x here. So 15 times 21 is 315. Then we're going to divide by the 9, which is going to give us 35. So x equals 35 is our result. How many of you had the first two correct? Okay, good. Number 3 is where the confusion really starts. Because the x appears twice here, we cannot just cross multiply and divide. We have to do the full cross multiplication. So here we got 24 times 6 is 144. Going this way, we have x times x, which is x squared. The two cross products have to equal each other. X squared has to equal 144. Now we look at solving this for x. X has been squared, so to get it by itself, we would have to square root. The square root of 144 is 12. Technically, the square root of 144 is 12 and negative 12, but we'll only worry about the positive result. Number 4 here is also kind of complex. So we've got 15 times 7, which is 105. Going the other direction, that's a little bit more complicated cross product. 2x minus 3 times 21, well, I'm going to write it as 21 times 2x minus 3. And now those two have to be equal. So 21 times 2x minus 3 has to equal 105. Now to solve this, we see parentheses. We can't combine anything inside the parentheses. So we have to ask, what can we do to the parentheses? And that's going to be multiplying by the 21. So 21 times 2x is 42x. 21 times negative 3 is negative 63. And that still equals 105. What's next? Add 63. Good. So we've got 42x equals 168. Finally, we would divide by 42. Good. X equals 4. And as always, we could go back and test it out, just like any other equation. 2 times 4 minus 3. Well, 2 times 4 is 8 minus 3 is 5. So we'd have 5 over 15. Is that equivalent to 7 over 21? And both of them would reduce to 1/3. So they are equivalent. So now I'm going to reach back a couple classes here and see what you remember. I want you to reduce (18) x to the 8th y squared over 24 x to the 5th y to the 5th And then I'll also have you reduce 32 x y squared z to the fifth over 20 x squared y z squared. Have you reduce those two, and we'll talk about them in just a second. Both of them are just reducing. It's easiest when we have the variables, at least it's easiest for me when we have the variables involved. If I take out the numbers and simplify the numbers first, and then come back and work with the variables. So I'm going to look at the 18 over 24 here. What can both of those be divided by? 6. Perfect. So 18 divided by 6 is 3. 24 divided by 6 is 4. So I get 3 over 4. So I know my answer, there'll be a 3 in the numerator and 4 in the denominator. So now for the variables, we have to decide two things. One, we have to decide whether it's going to be in the numerator or the denominator. And two, what its power is going to be. So for the x, will it end up in the numerator or denominator? Numerator, because we have x to the 8th and x to the 5th. 8 is bigger than 5, so it's going to end up in the numerator. What power is it going to have? 3. Good. 8 minus 5 is 3, so x to the 3rd. Where's the y going to end up? Denominator. We've got y to the 2nd, y to the 5th. 5 is bigger than 2, so it ends up on bottom with a power of 3. 5 minus 2 is 3. So 3x to the 3rd over 4y to the 3rd. Any questions there? Okay. The next one over here, we've got 32 and 20. I'm going to do the numbers again first. What can both of those be divided by? 4 will work. 32 divided by 4 is 8. 20 divided by 4 is 5. Can I change that to 1 and 3/5? No. Good answer. We cannot change these into mixed numbers because of the variables in there. We don't know what value those variables have. So we don't know whether this truly is a mixed number or not. So anyway, we've got 8 over 5 is going to be in our result. Now where's the x going to go? X is in the denominator and a power of 1, just x. Think of this as x to the 1, 2 minus 1 is 1, so it's x to the 1 or just x. Y is going to be numerator with a power of 1, so just y. And z is going to be numerator with a power of 3. So 8y z to the 3rd over 5x. Any questions on either of those? Anybody get both of those right? Oh, good handful. Good deal. Are there any questions off of the Math Lab homework we've had the last couple of classes? Anything there we want to go over? Okay. Well, then we can jump into our new material for the night. What we're going to be looking at tonight is more of these fractions. And we're going to be looking at operations with those fractions. Now, before we get into that, things to remember. When we add or subtract, first of all, we must have the same name. For fractions, that becomes that common denominator that we've mentioned. Now, we always combine the counts when we do operations with numbers, but we keep the same name. So let's take a look at what that looks like. So if I have fractions that already have that same denominator, like 3/7 plus 2/7, they have the same name, so I can go ahead and add them. We combine the counts. That would be adding the numerators. 3 plus 2 makes 5. And then we keep that same name, which is going to be the 7th, the denominator of 7. Now, we don't get that lucky very often where they have that common denominator already. Most of the time, we're going to see problems like this. The 1/4 plus 2/5, where they have different names, so we cannot add them the way they appear. We are going to have to change their name to give them common denominators. To do that, the first step is to figure out what that common denominator is going to be. So let's figure out how are we going to find common denominators. There are actually a few processes for finding the common denominators. One of them is just to multiply denominators. Here I could just do 4 times 5. Equals 20. That is a common denominator. However, it might not be the least common denominator. Now, we do not have to have the least common denominator. It's easier if we do. We've been told most of our life, most likely, that we have to have it. But we don't. Any common denominator will work. It just might be a little more effort, a few more steps that we have to do if it's not the least one. So other things that we can do other than just multiplying denominators, we can make lists. What I mean by making lists, well, we can count up by 5s and 4s and see where they match up. For example, 5s, it would be 5, 10, 15, 20, 25, 30, and so on. And we could keep going if we needed to. For 4s, it would be 4. What's 4 plus 4? 8 plus another 4. 12 plus another 4. 16 plus another 4. 20, there we have a match, so we can stop there. 20 appears in both lists. It's the smallest number that appears in both lists. If we kept going, we would find 40, 120, 160, 60, 80, 100. There's a bunch of numbers that will be in both lists. That's the smallest one in both lists. So that's that least common denominator. The third method we could use is that factor and find the LCM, least common multiple, like we did a couple weeks ago. When we have algebraic fractions, that's the method we're most likely going to use. So back up to our fractions at hand here, the 1/4 plus 2/5. Both of the first two methods gave us a common denominator of 20. Now, I tend to add things vertically, so I'm going to set these up vertically to add. Common denominator is going to be 20, so I'm going to have to change both of them to have a denominator of 20. And a little bit more review from last week. To figure out what this becomes, what do you multiply 4 by to make 20? 5, so I have to do the same thing to the numerator. 1 times 5 is 5. Down here, what do you multiply the 5 by to make 20? 4, so what do we do to the 2? Times 4 to make 8. Now that we have common denominators, we go that process again. Combine the counts. 5 plus 8 makes 13. and we keep the same name, 20ths. So as you can see here, the real difficulty comes in just finding the common denominator and getting it converted. So let's try. I'm just going to set these up vertically. 1/8 plus 5/6. Let's find the common denominator. Now I could just do 8 times 6 is 48. That is a common denominator and it would work, but it's not our least one. If I made lists, what would be? It would be 8, and then what would be next? 16 plus another 8 is 24, plus another 8, 32, plus another 8, 40. Let's stop there. For 6, it would be 6, and then plus 6 would be 12, plus another 6, 18, plus another 6, 24. So if we make lists, we see that 24 is the least common denominator of those two, smaller than the 48. If we had kept going with our lists, both lists would have included the 48. But we have a common denominator that is smaller, the 24. If we wanted to factor, what we would do is we'd do the 8 and the 6, and we would factor them. 8 is, of course, 2 times 2 times 2. 6 is 2 times 3. And if you recall, for that least common multiple, what we look at two things. We look at first, what's in common? They both have a 2 in common. That's it. And now we analyze what they don't have in common. Well, the top one, the 8, has a 2 and another 2. So the bottom number needs to be multiplied by 2 and another 2. The bottom number has a 3, so we need to multiply the top number by 3. So 8 times 3 is 24. 6 times 2 is 12, times another 2 is 24. 24 is our common denominator. The nice thing about this factoring method is it's going to tell us, when we look at algebraic fractions, is actually going to tell us what we have to multiply the numerator and denominator of each by. If we make this into 24ths here, for the 1/8, what did we multiply 8 by to turn it into 24? Multiplied by 3, right? 8 times 3, 1 times 3 makes 3 24ths. Down here, 6 times, well, 2 times 2 is 4. So it's 6 times 4 to make 24. 5 times 4 makes 20. Now we add those up. 3 20ths, or 3 24ths plus 20 24ths. We combine the counts. 3 plus 20 is 23, and we keep the same name. Now I had said we could just multiply to get that common denominator 48. What would have happened if we had used the 48 as our common denominator? Well, the short answer is we get the same answer. Just a little more work. It'd be 8 times 6 to make 48, so it'd be 1 times 6 to make 6. 6 times 8 makes 48, so 5 times 8 makes 40. We would add there, 6 and 40 make 46 over 48, but we see that both of those numbers can be divided by 2. So we reduce by 2 to get 23 over 24. So you can see we get the same result. It just took an extra step because we had to reduce it when we were done. So let's look at 1/6 plus 3/4. First thing is I'm going to have you guys tell me, what is the common denominator going to be? 12 is going to be our least common denominator. Could have also used 24. 4 times 6 is 24. Now, whatever method you use, many of you probably at this point can look at the 4 and the 6 and probably figure out the common denominator in your head if you've done a lot of work with fractions or with multiples. So anyway, what's this going to become here? The 1/6 becomes how many 12s? 2, good. 6 times 2 to make 12. 1 times 2 is 2. What's this going to become here? Careful. There you go. 4 times 3 makes 12. 3 times 3 makes 9. So you have 2 12ths and 9 12ths. That adds to make 11 12ths. Okay, in your notes, I'm going to have you guys try this one quick. 7 12ths plus 1/4. What do we get for common denominator? Somebody be brave. 24 would work. There is a smaller one we could use. 12. Sometimes one of the denominators is already the common denominator. So if we use 12, the 7 12ths does not have to change. 1/4 would become 4 times 3, so 1 times 3 is 3. We would add to get 7 plus 3 is 10 12ths. Now that still has to be reduced. Both of those can divide by 2 to give us 5/6. So even though we use the least common denominator, we still sometimes have to reduce our answers. Now if you'd used the 24th, you would have got 20 24ths, still reduce to 5/6. Subtraction. 3/4 minus 1/3. So again, I'm going to rate these vertically. What's our common denominator going to be? 12. Perfect. 3/4 is going to become 4 times 3, so 3 times 3 is 9 12ths. Perfect. 1/3 is going to become 4. There we go. So 4 12ths. So we've got 9 12ths minus 4 12ths. So we're subtracting. 9 minus 4 makes 5, and we keep the 12. I'm going to try this one in your notes. 5/6 minus 5/8. Again. What'd you come up with for a common denominator? 24. Perfect. So 5/6 becomes 20 24ths. Good. 5/8 becomes 15 24ths. We subtract to get 20 minus 15 is 5, and we keep the 24. Perfect. Okay. Next, we're going to look at multiplying. 1/4 times 2/5. Now, multiplying and dividing, if you recall, first of all, we do not need the same name. So for fractions, that's going to mean no common denominator. And second, obviously we combine the counts, because we always do when we calculate with numbers. And we also combine the names. So what that means up here is we multiply the numerators. 1 times 2 is 2. That's combining the counts. Then we also combine the names. That's multiplying the denominators. 4 times 5 is 20. Now we look at that answer of 2 over 20 and we notice both numbers can divide by 2, exactly. So that gives us 1/10. Now some of you might have been looking at this original problem wondering, why didn't he cross cancel? Others right about now might be wondering, what's cross cancel? Well, if we look at that, the numerator of our answer is just going to become the two numerators multiplied together. The denominator is just going to become the two denominators multiplied together. We notice that the 4 and the 2 can both be reduced or divided by 2. So we can actually do that before we multiply. 4 and 2. 4 divided by 2 is 2. 2 divided by 2 is 1. Now when we go to multiply the numbers, 1 times 1 is 1. 2 times 5 is 10. So we reduced it before we multiplied. Now in a problem like this one, it's about the same amount of effort, same amount of work either way. But if I give you a problem like this, 24/25 times 35/36, I could multiply that out and get 24 times 35 is 840, and 25 times 36 is 900. Well, 840 over 900 is kind of ugly to reduce, but we could reduce it down. Or I could look at 24/25 times 35 over 36. And I could cross cancel. What can cross cancel here? 25 and 35 can both divide by 5. Good. 35 divided by 5 is 7. 25 divided by 5 is 5. Well, the 24 and 36 can also be reduced. Both of them can be divided by 6 is 1. 24 divided by 6 would be 4. 36 divided by 6 would be 6. Now we look at those, 4 and 6 can still both be divided by 2. 4 divided by 2 is 2, and 6 divided by 2 is 3. Now there's nothing more that can reduce, so we'll multiply. 2 times 7 is a numerator of 14. 5 times 3 is a denominator of 15. We get 14/15. Up here, I'm assuming that most of you don't look at that and see right away that they can both divide by 60. But you can see that they both end in a 0, so they both divide by 10. So 84 over 90. They maybe both divide by 2, would be 42 over 45. And then, if you look closely, they both still divide by 3 to give you 14/15. To me, it's a lot easier when you have bigger numbers like that to reduce before you multiply. So I'm going to have you guys try one. 8/27 times 9/16. See what you come up with in your notes. We'll talk about it in a second. So as we look at this one, there's a couple of things that we can cross cancel. What's one of them? 8 and 16 can both divide by 8. So 8 divided by 8 is 1. 16 divided by 8 is 2. Anything else? 27 and 9 both divide by 9. What's 9 divided by 9? 1. 27 divided by 9? 3. So now we multiply. 1 times 1 is 1. 3 times 2 is 6. Any questions there? Okay. Just like any other operation, or any other type of number, I should say, division is the one operation with fractions that has been twisted and changed and mutilated beyond recognition. When we said before that division follows the same rules as multiplication. When we multiplied straight across. So when we divide, can I divide straight across? Can I do, oops, helps if I have my 1 on my 12 there. Can I do 12 divided by 4 is 3? You bet. 25 divided by 5 is 5. Does that work? Is that the correct answer? It is. Would it work every time? Sure. So why don't we do that? Well, because the numbers aren't always quite that cooperative. If we have 3/4 divided by 2/3, well, 3 divided by 2 is 1.5. That isn't terrible. But 4 divided by 3 would be 1.333333. That isn't going to work so well. So we can't just divide straight across there without doing some major adjusting. How were you guys taught to do that division? No. Well, the operation operates on the number that comes after it. Just like, when we're adding and subtracting with the negatives, it's the number that came after it that changed. So the division here is operating on the 2/3. When we're dividing fractions, we change it to multiplying by the reciprocal. So the reciprocal is just a fraction that's been flipped over. You've exchanged the numerator and the denominator. 2 over 3 becomes 3 over 2. And now it's multiplication. 3 times 3 is 9. 4 times 2 is 8. Now, of course, that's a mixed number. That can be reduced to what? 1 1/8. Believe it or not, that process of multiplying by a reciprocal came from this process that we saw up here. Years ago, what would have been done here when we had 3/4 divided by 2/3 is we would have looked at the number we are dividing by, the 2/3. Is that reduced as far as it can go? Yes, it is. So then we would have multiplied the numerator times the denominator. 2 times 3 is 6. We would use that 6 to rename the first fraction. So 3/4 would be multiplied by 6 over 6. What is 3 times 6? 18, and 4 times 6? 24. Now, 3/4 and 18 over 24 are identical. They're the exact same value. We've just changed its appearance. So now we divide by the 2/3. 18 divided by 2 is 9. 24 divided by 3 is 8. That's 9/8, or 1 1/8. Well, how did we get from this mess to multiplying by a reciprocal? Well, it's not as big of a jump as you might imagine. At one point, somebody looked at this problem and said, we have 3/4 times 6 over 6, and then divided by 2/3. If we play with our order of operations a little bit, fudge the order of operations a little bit, and divide this first, What is 6 divided by 2? 3. And what's 6 divided by 3? 2. What we always get here is just this second fraction flipped over. So they gave that name reciprocal, just flipping over the fraction. And then all that's left is the 3/4 times that number. So multiplying by a reciprocal is just a shortcut that's skipping all of those other steps in this longer process. With that said, we're still going to use that shortcut of multiplying by the reciprocal. So if I have 7/8 divided by 1/5, what am I going to do to divide that out? Does the 7/8 change? No. What changes? We multiply by the 1/5 becomes 5/1. So now we multiply straight across. 7 times 5 is 35. 8 times 1 is 8. Now we do have an improper fraction here, so we're going to have to reduce it. 8 goes into 35 4 times. 4 times 8 is 32. 35 minus 32 is 3. That's 3 left over, so that is 8. Or sorry, 4 and 3/8 left over. What if I give you 2/3 divided by 3/4? I'm going to have you do that in your notes quick. We'll talk about it in a minute. So the 2/3 does not change. It becomes times what? 4/3. Good. 2 times 4 is 8. 3 times 3 is 9. We just get 8/9. Any questions? So before we get to our break, there's a couple of things I want to look at. One is this. How would I do a fraction times a whole number? 2/3 times 5. Perfect. I turn the 5 into a fraction by making it 5/1. So then multiply the numerators. 2 times 5 is 10. And then the denominators. 3 times 1 is 3. And of course, this has to be reduced. 10/3. 3 goes into 10. 3 times 3 is 9. So there's 1 left over. 3 1/3. Many of you probably could have reduced 10/3 to 3 1/3 without having to do the long division. What about 3/4 divided by 5? Perfect. We make that 5/1. And now we still have to do the reciprocal. So that'll be 3/4 times 1/5. Perfect. So now we multiply. 3 times 1 is 3. 4 times 5 is 20. That's 3/20. What if we have something like this? 5/8 divided by 15/16. Well, the 5/8 doesn't change. The first number never changes. Remember, the operation operates on the number that comes after it. But it is going to become times what? Reciprocal will be 16 over 15. Now, since this is multiplication, we can still cross cancel. 5 and 15 both divide by 5. 5 divided by 5 is 1. 15 divided by 5 is 3. 8 and 16 both divide by 8. What's 8 divided by 8? 1. 16 divided by 8? 2. Now we multiply. 1 times 2 is 2. 1 times 3 is 3. Now, 2/3 divided by 3/4. Can I cross cancel my 2 and my 4? No, why not? Yeah, because right now it is still division. We can only cross cancel when it's multiplication. This has to become 2/3 times 4 over 3. Once it's multiplication, then we can cross cancel. Here, unfortunately, there's nothing that does cross cancel. We just get 8/9. Okay, it is time for our break, so let's go ahead and take our break. We'll come back at 4:30 and keep going. Well, at this point, I'm sure you're looking at it thinking this stuff isn't so bad. Well, time to take it to that next step. Something like this. Throwing those variables in there does not change much. It's the exact same process. So I'm going to write these, since I'm adding here, I'm going to write them vertically again. Now in this one, my denominators are numerical yet. I have 5 and 10. What would the common denominator be for 5 and 10? Just 10. Perfect. What do I have to do to a 5 to turn it into a 10? Times 2, right? So I have to do the same to the numerator. 2a times 2 is 4a. Now the 3a over 10, since that's just going to stay tenths, that's just going to stay 3a. Now I have the common denominator of 10. I am going to combine my numerators. 4a plus 3a makes 7a over 10. Well, that's not so bad. So let's try 5 over 6a squared plus 1 over 8a squared. Our common denominator, if I look at my 6a squared and my 8a squared, for common multiples, remember we would factor. Factoring 6 would be 2 times 3. A squared is just a times a. For 8a squared, well, 8 is just 2 times 2 times 2. A squared is a times a. If we look at what they have in common, they have a 2, they have an a, and they have another a. The top one has a 3 that we need to multiply the bottom one by. The bottom one has these two 2's. So that means I have to multiply the top by two 2's or by 4. 6a squared times 4 is 24a squared. What do I have to do to the 5? Well, also times 4 gives me 20. What did I have to do to the 8a squared to make a 24a squared? Times 3. So what do I do to the 1? Times 3 to make 3. So now we go to add. 20 plus 3 is 23. Over, we keep the common denominator of 24a squared. Now here I factored this out, but remember a couple of classes ago, we worked with these and we found the shortcut. If I had something like 12x to the 5th y and 18x to the 3rd y to the 3rd, the least common multiple LCM, which is just what the least common denominator is, was found. We could take the LCM of the numbers 12 and 18. What is the smallest number that both 12 and 18 go into? 36. And we take the largest power of each variable. So for x, it's going to be what? X to the 5th. For y, it's going to be to the 3rd. Very good. So if I have 10 x to the 3rd, y squared z to the 5th, and 15 x y to the 3rd. My least common multiple. For 10 and 15, what's the least common multiple of those numbers? 30, very good. For the x, well, it's either going to be 3 or 1. It's the largest power, so it'll be 3. How about y? Y to the 3rd. Does the z appear in the least common multiple? It does. Z to the 5th is its largest power. I could think of this down here as being z to the 0 if I wanted to. But every variable appears in the least common multiple. If it appears in either one, it's in the least common multiple. So 30x to the 3rd, y to the 3rd, z to the 5th would be the least common multiple. So if I have 7 over 10x plus 3 over 5x squared. My least common denominator, or my least common multiple, for 10 and 5 would be 10. How about for the x? X squared. So 10x squared is my least common denominator. Now here I have 10x, and I want to turn it into a 10x squared. What do I have to multiply by? X. 10x times x makes 10x squared. So the 7 must also be multiplied by x. That makes 7x. 5x squared, what do we have to multiply it by to turn it into a 10x squared? 2. 5x squared times 2 is 10x squared. So we have to multiply our numerator there, the 3, by 2 to get 6. Now here's the tricky part. We add 7x over 10x squared plus 6 over 10x squared. We combine the counts. We add the numerators. 7x plus 6 is just 7x plus 6. They have different names. We cannot combine. We can't add 7x to 6. But we do have now a common denominator of 10x squared. I'm going to have you guys try one in your notes here. I'll leave that up there so we can see it. We're going to try 3 over 4y squared plus 1 over 6y. I'm going to have you try that one in your notes, and we'll talk about it in just a minute. So as we look at this one, we have 4y squared for denominator and 6y for the other denominator. What's our common denominator going to be? 12y squared. Beautiful. What do we have to do to the 4y squared to turn it into 12y squared? Times 3. Good. So we do 3 times 3 to make 9. So it's 9 over 12y squared. What do we do to this 6y to turn it into 12y squared? Multiply by 2y. So 1 times 2y is 2y. Now we go to add. 9 plus 2y is simply 9 plus 2y over 12y squared. How many of you managed to get that? A good share. Okay, any questions on getting that? Okay, we will see plenty of practice over the next couple of classes, so hang in with it. So now the next step is, what if we have 5x over 8 minus x over 6? So we're going to do a similar thing. 5x over 8, x over 6. Just like addition, we must have a common denominator. Well, we have 8 and 6. What's our common denominator going to be? 24. Very good. The variables, the x's, don't affect that a bit in this case. What do we have to do to the 8 to turn it into a 24? Times 3. So 5x times 3 gives us 15x. Good. What's this going to become up here above the 24? 4x. Good. 6 times 4 to make 24. So x times 4 makes 4x. Now we add 15x over 24 plus 4x over 24 gives us 15x plus 4x is, minus, sorry, 11x over 24. Any questions there? And of course, it gets worse, just like it did with the addition. We might have 3 over 8 x squared y minus 5 over 6 x y to the third. Common denominator. Well, let's start with the numbers. 8 and 6. What's the common denominator for those two numbers going to be? $24. How about for x? X squared is the largest power. And y? Y to the third. So I'm going to stop there. Any questions on how we found the 24x squared y to the third? Okay. So now 8 times 3 makes 24. Oops, I don't know why I put an 8 there. 8 times 3 makes 24. X squared, we don't have to do anything to make that x squared. Y times y squared makes y to the third. So we multiplied by 3y squared. We have to do the same to the numerator. 3 times 3y squared is 9y squared. Down here, to make 6 into 24, it's times 4. X into x squared is times x. Y to the third is still y to the third, so we didn't do anything to that. So we multiply the numerator by the 4x. 5 times 4x is 20x. Now we are subtracting. 9y squared minus 20x is just 9y squared minus 20x over 24x squared y to the third. Any questions? Okay, let's look at multiplication now. Let's have 7x over 12y squared times 6y over 35x to the third. There are a couple of different ways I can go about doing multiplication with these. The first way, probably the one that produces the fewest mistakes, is to just multiply them out and then reduce later. For example, 7x times 6y. Well, 7 times 6 is 42. X times y is just xy. 12y squared times 35x to the third. 12 times 35 is 420. Y squared times x to the third is x to the third y squared. And now I would reduce this just like I have with other fractions. I would pull out the 42 over 420. What can both of those be divided by? 42, good catch. 42 divided by 42 is 1. 420 divided by 42 is 10. So in my answer, I have 1 in the numerator, 10 in the denominator. Where does the x end up? In the bottom, power of 2, good. Think of that as x to the 1, so x to the third is larger, ends up on bottom. 3 minus 1 is 2. And how about the y? Bottom, power of 1, or just y. 2 times 1 is 1, so x to the 1, or 2 minus 1 is 1, so y to the 1, or just y. So that is 1 over 10x squared y. We might have 15 y to the fifth over 16 x to the third times oh, that ain't going to work very well. Let me try to change that. Oh, let's do 12 x over 25 y squared. So we multiply this out. 5y to the 5th times 12x. Well, 5 times 12 is 60. Y to the 5th times x is just x, y to the 5th. Just putting them in alphabetical order. 16x to the 3rd times 25y squared. 16 times 25 is 400. X to the 3rd times y squared is x to the 3rd y squared. Again, it's a matter now of reducing this. 60 over 400. Both of those can be reduced by what? Well, they can both be reduced by 10 because they end in zeros. We could start with that if we wanted to. If we look a little closer, they can both be reduced by 20. 60 divided by 20 is 3. 400 divided by 20 is 20. So over here we have 3 on numerator and 20 in the denominator. How about x? X is going to be on bottom, power of 2. How about y? Top. Y is on top, power of 3. Any questions? Many of you will probably prefer to do it the way I've done those, just because some people find cross-canceling and stuff confusing, and even more so confusing when we throw in the variables. But I do want to go back now and do this problem. With cross-canceling. That was y to the 5th. So if I wanted to cross-cancel this, what I would do, what makes it easier for me, is to pull out the numbers. Well, 25 and 5 both divide by 5. 5 divided by 5 is 1. 25 divided by 5 is 5. 16 and 12 can both be divided by 2, but they can also both be divided by 4. 16 divided by 4 is, or 12 divided by 4 is 3. 16 divided by 4 is 4. So I've reduced the numbers. 1 times 3 would be 3. 4 times 5 would be 20. That's the numerical part of our answer. Now the variables can also be cross-canceled. I'm just going to combine them out here. I've got y to the 5th and x. That's xy to the 5th. X to the 3rd y squared is x to the 3rd y squared. Then I'm just going to do the same thing that we did before. X ends up on bottom and it's squared. Y ends up on top and it's to the 3rd. This is the way I do it, but there's a lot to keep track of there. Like I said, many of you will probably find it easier just to multiply them out like this and then reduce it. I'm going to have you guys try one in your notes here. We're going to do 8 a to the 5th over 25 b squared times 15 b to the 3rd over 32a. I'm going to give you a couple minutes to do that one in your notes. So multiply it out. 8a to the 5th times 15b to the 3rd is 120. A to the 5th, b to the 3rd. 25b squared times 32a is 800 ab squared. Then I'm going to reduce 120 over 800. Both of those can be divided by 20. Actually, both of those can be divided by 40 to give me 3 over 20. I seem to be stuck in a rut of 3 over 20 here, don't I? Then where's the a go? Top power of 4. B goes top power of 1, or just b. So 3 a to the 4th b over 20. Well, the good news, division isn't much harder. 7x over 8 y squared divided by 5x to the 3rd over 12y. Because when we divide fractions, all we're going to do is turn it into multiplication by the reciprocal. So the 7x over 8y squared does not change. It becomes times reciprocal here is 12y over 5x to the 3rd. And now it's just a multiplication problem. 7x times 12y is 84xy. 8y squared times 5x to the 3rd is 40x to the 3rd y squared. And we just have to reduce. 84 over 40, both of those can be divided by 4. 84 divided by 4 is 21. 40 divided by 4 is 10. Can I change that into 2 1/10? No, I cannot. Because there's variables there, I do have to leave it, even though the larger number is on top. It looks like an improper fraction, but it isn't necessarily because we don't know what the variables are. How about the variables? What do we end up with? How about x? Bottom power of 2. And y? Bottom and just y. So 21 over 10x squared y. Any questions? Okay, well, that is quite a mouthful for one night. I just wanted to look here quick about our next test. I know it's scheduled in my math lab, but it looks like it should be coming up here next week, Thursday, if I remember right. That looks to be right. I'm just going to make sure here. October 12th. So yes, next week, Thursday, is our next test. So make sure you are preparing for that. There is a new quiz. It is due tomorrow. That is Wednesday, 11:59 p.m. And there is a new homework due for class on Thursday. I'll let you guys have the last 18 minutes here. If you want to get started on homework or work on the quiz or finish up homework from last class, I'll be here till 5:20.